Hello students, straight back again. Today you'll be going over your practice problems for section 2.1. Should have already completed these. Now you'll be checking them. Or if you are struggling with them, you could be looking at them, looking at one or two of them and then trying to figure out the rest. But always try to do things on your own. First question, how many centigrams are in a gram? And here's where you just need to remember our metric prefixes. So learn these metric prefixes, know what they mean. Just takes a lot of time looking them up every time. So centa is 100, so that means in 1 gram we have 100 centigrams. Or, many times we'll write that as 10 to the second centigrams. Centigrams. Another conversion here. How many liters are in a kiloliter? So, kilo means 1,000. So 1 kiloliter is 1,000 liters, or many times again 10 to the third liters. As we do conversions, this exponential notation many times works better. How many nanoseconds are in a second? So a prefix of nano. So 1 second, nano means a billionth. So 1 second is a billion nanoseconds, and there the exponential notation is much nicer, and that would be 10 to the 9th nanoseconds. And other meters in a kilometer. 1 kilometer is 1,000. Kilo means 1,000 meters, or 10 to the third meters. Density calculation. Next few problems. And a formula for density. Density equals mass divided by volume, and that's what we're trying to find, is density. Here's our mass, here's our volume. So it equals 3.8 grams divided by 2.0 cubic centimeters, which gives us 1.9 grams per centimeter cubed. Could also write that as 1.9 grams per milliliter, as 1 centimeter cubed is the same as 1 milliliter. Because these are the same, we can always interchange them. What is the density? Again, density is mass divided by volume. Our mass is 8.8 grams. Volume 5.5 milliliters. These are both essentially multiples of 11, or more precisely 1.1. If you want to do this one in your head, you could always type it in a calculator. But you could think of it as 8 over 5, which is 1 3/5, and 3/5 is 0.6. 1.6 grams per milliliter, or 1.6 grams per cubic centimeter. Same things. Typically we use milliliters when we're talking about liquids, and we'd use cubic centimeters talking about solids, but they are interchangeable, so it doesn't make any difference. What is the density again? Density equals mass divided by volume. One more time. There's our mass, 10.0 grams. There's our volume, 11.6 milliliters. This one you just want to type into your calculator. And when you get to the proper number of sig figs, 0.862 grams per milliliter. Or again, it could be 0.862 grams per cubic centimeter. Either acceptable answers. Number 8. Here, we want to know which of these metals it is, so we are going to find their density. And the density is the mass divided by the volume. Our mass, 34.65 grams, divided by the volume, 3.3 milliliters. Not worrying about sig figs this time. I run it through and we find 10.5 grams per milliliter, which would be the same as 10.5 grams per cubic centimeter. And we come up here and we see that. So that means, yeah, silver. Now this one, change it up a bit. This one we want to know what the volume is. So we start with our base formula, density equals mass divided by volume. We rearrange that formula to get volume equals mass divided by density, and we can always just switch these two around. Easy way to remember it. So volume equals mass, 4.8 grams divided by density, 2.18 grams per cubic centimeter. Grams divide out grams. Do a little division here. Going to keep a couple significant digits. And we get 2.2 cubic centimeters. Could also write that as 2.2 milliliters. This is a solid. I'd leave it as cubic centimeters. But if you had milliliters, that would have been okay too. And this one, we want to know what the mass is. And we're still working with a density problem. Density equals mass divided by volume. Rearrange it, mass is density times volume. And if you're trying to find this one, just multiply those two. Density times volume, change that to a V. So mass equals density. There's our density. 11.34 grams per cubic centimeter times the volume, which is 1.5 milliliters. As this displaced 1.5 milliliters of water, means the volume of it had to be 1.5 milliliters also. Now, milliliters and cubic centimeters divide out because they're the same thing. Here we're going to multiply, keep 2 sig figs because of the 1.5. And we get 17 grams. We move into some temperature conversions. Convert each temperature reported in degrees Celsius to Kelvin. So if we want to go from Celsius to Kelvin, that means Kelvin is degrees Celsius plus 273. So all I have to do is take and add 273 to each of these. I'll just write it down for each of them. And when we add that up, we get 327 Kelvin for A. For B, add that up, you'd actually be subtracting here. 273 minus 54, but 219 Kelvin. And 273 N15 gives us 288 Kelvin. So pretty simple little conversion between Celsius and Kelvin. Something they're going to have to be doing from time to time as you move through chemistry. Rarely will we convert with degrees Fahrenheit, but occasionally we might. And here we're trying to go from kelvins to degrees Celsius. So our base formula is degrees Celsius equals Kelvin minus 273. So that means each of these I have to subtract 273 from. And we get negative 241 K. Remember, we do not use a degree symbol with kelvins. We've got degrees Celsius, degrees Fahrenheit, and then we got Kelvin. 0 minus 273, nice easy one, negative 273 kelvins. And then 281 minus 273, and that one's just 8 kelvins. So that was our practice problems for section 2.1. Hope you did well, hope you understand it. Until next time, strike.